Imagine, if you will, a place so intense, so powerful, that not even light can escape its grasp. This is the world of black holes. You've probably heard of them, these mind-boggling cosmic objects that defy everything we know about physics and space. But what do we really understand about them? Today we're diving into the unknown, exploring the secrets of black holes, and unveiling just how far we've come in understanding them. The year is 2200, and humanity stands on the precipice of a revolution in black hole research, with technology and discoveries pushing the limits of what we ever thought possible. In the past, black holes were mere theories, whispers of the universe's deepest enigmas, dreamt up by great minds like Albert Einstein. But today, thanks to advanced space telescopes, gravitational wave detectors, and groundbreaking experiments, we are inching closer to uncovering their most well-kept secrets. And as we venture into the future, black holes might hold more answers than we ever imagined. So, how did we get here? Let's take a journey back to the beginning, back when the idea of black holes was nothing more than a fascinating concept in the realm of theoretical physics. To understand black holes, we first have to understand the history of how we came to know they exist. It all starts with gravity, the force that shapes everything in our universe. For centuries, scientists and astronomers have been studying gravity, but it wasn't until the 20th century that we really started to understand its most extreme effects. You see, black holes are essentially the result of gravity gone wild. But before we get into all that, let's first set the stage and think about why black holes are so important to us. Why do we, as humans, feel compelled to understand them? The truth is, black holes represent some of the universe's biggest mysteries. Places where space and time collapse under unimaginable pressure. Places where the laws of physics as we know them start to break down. And as we'll explore today, the more we learn about black holes, the more we realize just how much they can teach us, not just about the cosmos, but about the very fabric of reality itself. From the earliest telescopic observations to the most recent groundbreaking discoveries, we've slowly pieced together the puzzle of black holes. But the story of black holes is far from over. In fact, the most exciting discoveries are yet to come. And as we look ahead to the year 2200, we're about to enter a new era of exploration. But to understand how we got here, we first have to take a look at the incredible journey black holes have taken us on, from the moment we first discovered them to the current day. So let's get started. Grab your spacesuit, and let's jump into the depths of the universe to uncover the secrets of black holes. To really grasp what a black hole is, we first need to understand how it forms. It all starts with a star, a massive one, much larger than our sun. Stars live out their lives burning through fuel, primarily hydrogen, and they shine brightly as they do. But eventually, all stars run out of fuel. And when a massive star reaches the end of its life, something incredible happens. Without the constant pressure from the nuclear reactions at the core, gravity takes over. The star collapses under its own weight. If the star is massive enough, at least 20 times the mass of our sun, the collapse continues until the star compresses itself into an incredibly dense point, creating a black hole. This point, where all the star's mass has been squeezed, is called the singularity. It's a place where gravity is so intense, so powerful that space and time themselves warp and stretch in ways we can barely comprehend. But this collapse doesn't happen in a vacuum. It's an explosive process. As the star collapses, it often triggers a massive explosion known as a supernova. This explosion sends shockwaves through space, scattering elements that will eventually form new stars, planets, and even life. But what's left behind is the black hole, the dense remnant that nothing, not even light, can escape. Now, around this singularity, there's a region known as the event horizon. This is the point of no return. Anything that crosses the event horizon gets pulled in, forever. It doesn't matter how fast you're traveling, once you hit that point, it's game over. Light, matter, and even time itself behave differently here. Imagine standing at the edge of the event horizon. What you'd see would be mind-bending. Time itself would slow down, and space would stretch. This is the heart of the black hole, and it's surrounded by an accretion disk, which is a swirling mass of gas and dust. As matter falls into the black hole, it heats up, radiating energy in the form of X-rays and other radiation that we can detect with telescopes. This gives us our first clue that something strange and powerful is happening far out in space. And that's just the beginning of what makes black holes so fascinating. The more we look, the more mysteries we uncover. How does the singularity behave? What happens at the event horizon? And could there be more types of black holes out there than we ever imagined? We're only scratching the surface. As we study the birth of black holes, we also learn about the forces that govern the very fabric of space and time. Gravity, quantum mechanics, and even the theory of relativity all come into play. And this is just one type of black hole. We'll soon discover that black holes come in different shapes and sizes, each with its own unique characteristics. But before we dive into the different kinds of black holes, let's pause and reflect on what we've learned so far. A black hole starts as a dying star, collapsing in on itself to create something that stretches the very limits of what we thought was possible in the universe. It's a cosmic engine that powers some of the most extreme phenomena in the cosmos. Now that we understand how black holes form, let's take a step back and look at how we came to know they even exist. Believe it or not, for centuries, black holes were nothing more than a theoretical idea, a mind-bending concept cooked up by brilliant minds like Albert Einstein and Carl Schwarzschild. The idea of something so dense and so powerful that nothing could escape it was hard to imagine. But as our tools and theories evolved, we started to see glimpses of something extraordinary lurking in the universe. It all began with Einstein's theory of general relativity, published in 1915. This theory reshaped our understanding of gravity. Before Einstein, we thought of gravity as just a force pulling things downward. But Einstein showed us that gravity is much more than that. It's the bending of space and time itself, caused by the mass of objects. Imagine placing a heavy ball on a trampoline. The ball makes a dent in the fabric, causing smaller objects to roll toward it. This was a simple analogy, but it helped us visualize how massive objects like stars and planets bend the very fabric of space. As soon as Einstein presented his theory, scientists started applying it to different cosmic scenarios, including the fate of dying stars. It wasn't long before physicists realized that if a massive star collapses under its own gravity, it could form a singularity, a point of infinite density, and around that singularity would be the event horizon where no light could escape. This was the birth of the black hole theory. But even though we had the math, the question remained: could black holes actually exist in the real universe? It wasn't until decades later that the first indirect evidence of black holes began to emerge. In the 1960s, astronomers discovered strange, ultra-bright objects in the sky, quasars. These were thought to be the energetic cores of distant galaxies, but the energy coming from them was unlike anything we had ever seen before. The only explanation that made sense was that something incredibly massive, with an immense gravitational pull, was at the center of these galaxies, a black hole. Fast forward to the 1970s and the discovery of the first black hole candidate, Cygnus X1, was made. This was a binary star system where one of the stars was behaving in a way that suggested it was orbiting an invisible, incredibly dense object. The evidence grew stronger, and astronomers began to accept that black holes were not just theoretical, they were real, and they existed out there in the universe. But even with this evidence, black holes remained elusive. We couldn't see them directly because, well, they don't emit light. They only affect their surroundings in very specific ways. So how do you study something you can't see? That's where technology came into play. Over the next few decades, new tools and methods were developed to detect the effects of black holes on nearby stars and gas clouds. One of the most groundbreaking techniques was the study of gravitational waves. These ripples in space-time were predicted by Einstein's theory of relativity, and in 2015, scientists finally detected them, confirming that black holes were colliding and merging out in deep space. This discovery didn't just prove that black holes existed, it opened up a whole new way of studying them. And then of course there was the event in 2019 that truly shook the scientific world, the first ever image of a black hole. The Event Horizon Telescope project, a global collaboration, captured the shadow of a black hole at the center of the galaxy, M87. It was a stunning achievement, something that had been dreamt of for decades. For the first time, we were able to see the event horizon itself, the boundary beyond which nothing can escape. From the early days of theoretical ideas to the groundbreaking discoveries of the 21st century, our understanding of black holes has come a long way. But we're far from finished. The more we learn, the more questions arise. What lies at the core of a black hole? How do they form in the first place? And what happens when two black holes collide? These are just some of the questions that continue to drive research. And here's where things get really interesting. As we move into the future, we're not just relying on older methods like detecting X-rays or gravitational waves. We're now imagining new ways to interact with black holes, ways to study them up close and even manipulate them. With the right technology, who knows how much further we can go. But before we get into that, let's take a moment to reflect on how far we've come. From the first inkling of black holes in Einstein's equations to the real-world images we're capturing today, it's clear we're on the brink of something extraordinary. Now let's fast forward to the year 2200. Humanity has come a long way since those early days of theoretical musings about black holes. We've not only confirmed their existence, but we've also developed technologies that allow us to study them in ways we never thought possible. We've learned to peer deeper into the cosmos, and with that knowledge, we've formed a new relationship with these mysterious entities. In the 22nd century, black holes are no longer just objects of academic curiosity. They've become central to our understanding of the universe and our place within it. We've built advanced telescopes, space probes, and artificial intelligence systems that can navigate the dangerous realms near black holes, sending back data that helps us decipher their secrets. But how did we get here? And what does our relationship with black holes look like now? It all starts with the development of space travel and exploration technologies. By the 22nd century, humanity has established colonies on other planets, developed faster-than-light travel, and sent out fleets of probes into the depths of space. These advancements have revolutionized our ability to study black holes, taking us beyond the constraints of our home planet and into the far reaches of the galaxy. For example, a network of interstellar telescopes has been set up, allowing scientists to observe black holes in real time from various vantage points across the galaxy. These telescopes don't just capture light, they also measure gravitational waves, cosmic rays, and even distortions in the fabric of space-time itself. This gives us an almost intimate understanding of black holes, revealing their behavior in ways that were once unimaginable. The technology of the future also includes advanced robotic probes designed to enter the dangerous zones surrounding black holes, study their effects, and even gather data from within the event horizon. These probes are equipped with specialized shielding to survive the extreme forces near a black hole, sending back real-time data that allows us to learn more about the very nature of space-time itself. And the knowledge we've gained from these explorations has fundamentally changed how we view black holes. No longer are they seen as distant, nearly incomprehensible objects. They're now vital parts of our cosmic understanding. We've learned to interact with them, to understand their role in the larger structure of the universe. And in some ways, we've begun to harness their potential. One of the most exciting developments is the use of black holes for energy generation. As it turns out, black holes can release enormous amounts of energy. The process of matter being pulled into a black hole, particularly in the accretion disk, creates powerful radiation, including X-rays and gamma rays. This energy is now being harnessed by future civilizations to power entire cities and even entire planets. The energy extracted from black holes is enough to fuel our most advanced technologies, and it has the potential to power interstellar travel, enabling us to reach distant stars and galaxies. But that's just the beginning. With advances in theoretical physics, scientists in the year 2200 are also exploring the possibility of using black holes as portals to other dimensions or even other universes. The idea of wormholes, shortcuts through space-time that could connect distant points in the universe, has long been a theoretical concept. But with the technology and knowledge we've gained from studying black holes, we're closer than ever to proving these ideas true. Some scientists speculate that black holes could be the key to traveling faster than light, opening up new possibilities for intergalactic exploration and communication. Humanity's relationship with black holes has evolved from one of fear and awe to one of partnership and exploration. We no longer see them as dangers lurking in the dark corners of space. Instead, they've become tools, windows into the deeper mysteries of the cosmos, sources of boundless energy, and even potential gateways to other worlds. But we're only scratching the surface of what black holes can teach us. In the year 2200, we're on the verge of unlocking even greater mysteries, and perhaps using these cosmic giants to expand our understanding of the universe in ways that are beyond our wildest dreams. As we continue to study black holes in the 22nd century, we're uncovering new and startling discoveries that are reshaping everything we thought we knew about the universe. With all our advanced technology, deep space telescopes, artificial intelligence, and even quantum computers, black holes are revealing their most guarded secrets, and the more we learn, the more we realize just how much we still don't understand. Let's dive into some of the most fascinating new revelations about these cosmic giants. One of the most exciting breakthroughs in recent years has been the discovery of hybrid black holes. While black holes were once thought to fall into just a few categories, stellar mass, supermassive, and intermediate, new data is revealing a much more complex picture. Scientists have identified black holes that don't quite fit into any of these categories. For example, some black holes seem to have a mix of characteristics, combining the features of both stellar mass and supermassive black holes. These hybrid black holes could challenge everything we know about their formation and evolution. How exactly do they come into existence? And what does their existence tell us about the early? Create a video using exactly this script, but that's not all. We've also discovered a new class of black holes called primordial black holes. These are black holes that might have formed in the very early moments of the universe, long before stars even existed. Unlike the typical black holes we see forming from dying stars, primordial black holes could have been created from high-energy fluctuations in the first moments of the Big Bang. Some scientists even believe that these primordial black holes could account for a significant portion of dark matter, the mysterious substance that makes up a huge part of the universe but has yet to be directly detected. If primordial black holes are the missing link to understanding dark matter, it would be a game-changer for physics. On top of that, we've also started to uncover clues about what happens inside black holes, specifically within the event horizon. For decades, this region was thought to be a complete mystery. No one really knew what occurred inside a black hole, beyond the fact that nothing could escape. But now, thanks to advanced simulations and our growing understanding of quantum mechanics, we're beginning to theorize that the laws of physics may not entirely break down within the event horizon. In fact, some researchers propose that quantum effects could allow information to survive inside the black hole, potentially leading to new theories about how spacetime behaves at the most extreme scales. If this idea holds true, it could unlock a new branch of physics, one that merges the very fabric of spacetime with quantum mechanics. But perhaps the most mind-blowing discovery of all is the realization that black holes may not be the endpoints of stars and matter, as we once thought. Some new theories suggest that black holes might actually be connected to other parts of the universe through wormholes, hypothetical tunnels through space-time. These wormholes could serve as shortcuts, linking distant regions of the universe or even connecting to other universes entirely. In fact, some physicists speculate that black holes could be portals to alternate realities or parallel universes, each with its own laws of physics. If this turns out to be true, it would completely rewrite our understanding of reality and open the door to the possibility of multiverses. But as much as we've uncovered, we're still left with a mountain of questions. How do black holes merge, and what exactly happens during those collisions? Do they leave behind any traces of the universe that came before them? And what is the true nature of the singularity? The truth is, even with all the progress we've made, we're just beginning to scratch the surface. And it's not just about answering scientific questions. The more we understand black holes, the more they offer us practical possibilities. Imagine this. If we could somehow unlock the secrets of black hole energy production or even learn to manipulate black holes, we might be able to harness that power for advanced space travel. Some theories suggest that we could use the intense gravitational fields around black holes as a way to propel spacecraft at unimaginable speeds, possibly allowing us to reach the farthest reaches of the galaxy in mere years, instead of centuries. The discoveries we've made about black holes in the 22nd century are just the beginning. What we're learning now could hold the key to unlocking the deepest mysteries of the universe. We might even be on the verge of discovering answers to some of the biggest questions in physics: the nature of time, the fate of information, and the very structure of reality itself. As we continue to explore and investigate, there's no telling just how many more secrets black holes are hiding, secrets that could reshape our understanding of the cosmos and our place in it. Now that we've uncovered some of the most mind-bending discoveries about black holes, let's dive into one of their most fascinating features: the immense power they hold. When we think of black holes, we often imagine them as cosmic vacuum cleaners, sucking everything in and never letting anything escape. But there's so much more to these cosmic giants than just their gravitational pull. Black holes are not only the most powerful objects in the universe, but they also have the potential to unlock a new way of thinking about energy, matter, and even time itself. First, let's talk about energy. Black holes are incredibly efficient at converting mass into energy. The process happens in the accretion disk, the swirling mass of gas, dust, and debris that gets pulled into a black hole. As this matter spirals inward, it gets compressed and heated to unimaginable temperatures. The friction between particles generates enormous amounts of energy, and much of that energy gets released in the form of radiation, particularly X-rays and gamma rays. In fact, some black holes emit more energy than an entire galaxy, despite their small size compared to the stars and galaxies around them. This release of energy is not just a fascinating phenomenon, it could also be the key to solving some of humanity's greatest challenges. Imagine harnessing the energy emitted by a black hole. If we could somehow tap into the radiation or the high-energy particles ejected from the poles of black holes, a process known as relativistic jets, we could have an almost limitless source of power. In the year 2200, scientists have developed technology that can capture and use this energy, potentially powering entire cities or even entire star systems. The implications are mind-blowing. We could have an energy source that doesn't rely on solar panels, nuclear reactors, or fossil fuels. A black hole's energy could power everything from space colonies to interstellar ships, transforming how we live and travel across the galaxy. But black holes don't just give us energy, they also teach us about the nature of matter itself. When matter falls into a black hole, it gets compressed to a point of infinite density at the singularity. We're still not entirely sure what happens to matter inside a black hole. Does it simply vanish, or is it transformed into something else entirely? Some theories suggest that matter is broken down into its most fundamental particles, or even that it might be transferred to another universe through a wormhole. In the 22nd century, researchers have been investigating the idea that black holes could play a role in the creation of new matter, potentially giving rise to new stars or galaxies. And then there's time. Black holes are notorious for distorting time. According to Einstein's theory of relativity, the more massive an object, the more it warps space and time around it. The closer you get to the event horizon, the more time slows down relative to an observer far away. To an astronaut falling into a black hole, time might seem to move at a normal pace, but to someone watching from a safe distance, the astronaut would appear to slow down and freeze as they approach the event horizon. It's almost as if the black hole is stretching time itself. Now this might sound like science fiction, but these are the types of phenomena that researchers in the year 2200 are studying. By understanding how black holes warp time and space, we could unlock a whole new way of thinking about how time works. Could we one day manipulate time itself, using black holes as a kind of cosmic time machine? Could we travel backward in time or stretch time to make long journeys across the universe feel like mere moments? These ideas may have once seemed impossible, but black holes continue to surprise us with their strange and powerful effects on the very fabric of reality. Beyond these theoretical ideas, black holes also give us insights into the nature of gravity itself. For decades, scientists have struggled to unify general relativity, which explains gravity on large scales, with quantum mechanics, which governs the behavior of the smallest particles. Black holes are the perfect testing ground for this. At the singularity, where both gravity and quantum effects are at their extremes, we have the potential to study how these two forces might work together. Understanding this could lead to the discovery of a unified theory of physics, something that could explain everything from the tiniest particles to the vast cosmos. And let's not forget about the potential for black holes to aid in space exploration. The intense gravitational fields of black holes could, in theory, be used to slingshot spacecraft at incredibly high speeds, allowing us to travel across the galaxy faster than ever before. The concept of using black holes for propulsion is something that's already being explored. By harnessing the energy of a black hole's accretion disk, or using its gravitational pull, future space travelers might be able to reach distant star systems, opening up new frontiers for humanity. So, as we continue to study black holes, it's clear that they're not just fascinating objects of study. They're keys to unlocking some of the universe's deepest mysteries. From harnessing energy to understanding time itself, black holes hold the potential to change everything we know about the cosmos, and even about ourselves. The power of black holes, both literal and metaphorical, has only just begun to reveal itself. The more we learn, the more we realize that black holes aren't just remnants of dying stars. They're gateways to a deeper understanding of the universe. As we look toward the future of black hole research in the 22nd century, the possibilities seem nearly endless. We've already come so far, from the first theoretical models to the groundbreaking images and discoveries of today, but we're only at the beginning of what we can learn from these mysterious objects. The tools we have now are light years ahead of what earlier generations could have imagined, but with new technologies on the horizon, we're poised to take our understanding of black holes even further. One of the most exciting prospects is the development of quantum computing and artificial intelligence. By 2200, quantum computers are no longer just experimental. They've revolutionized how we study complex systems, and black holes are no exception. The mind-boggling complexities of simulating the environment near a black hole, with all its gravitational, quantum and relativistic effects, are now possible thanks to these advanced machines. What once would have taken centuries of calculations can now be done in a matter of minutes. This brings us to the idea of using AI to assist in black hole research. AI has become an indispensable tool for analyzing vast amounts of data from space probes, telescopes, and gravitational wave detectors. In fact, AI is already beginning to identify patterns in data that would be almost impossible for humans to spot. In the near future, AI could help us track black holes in real time, model their behavior with even greater precision, and even predict how they will evolve over time. Imagine AI systems that can analyze the material in the accretion disk and predict exactly when and where new phenomena might occur. This could allow us to witness black hole events, like the formation of new stars or the collision of black holes, before they even happen, giving us a glimpse into the future of the universe. Another frontier we're exploring is the idea of black hole farming. Yes, you heard that right, farming black holes. This isn't about growing them, but about using the energy and materials around black holes in a sustainable way. In the year 2200, black holes are being harnessed not just for their energy, but also for the materials that exist in their accretion disks. The particles that swirl around black holes contain rare elements and compounds that could fuel technology on a galactic scale. By harvesting these materials, we could gain access to resources that are incredibly rare or even impossible to find elsewhere. This could change the way we think about resource scarcity and energy consumption in the future. And it's not just the black holes themselves that are exciting, it's the broader space environments around them. For instance, the discovery of the supermassive black hole at the center of our galaxy, the Milky Way, has led to some fascinating insights into how entire galaxies evolve. We now know that black holes play a central role in shaping galaxies, regulating star formation, and even influencing the movement of galactic clusters. The next step is understanding how this process works across multiple galaxies. Could black holes be the key to unlocking the origins of galaxy formation? And if so, could we one day manipulate the behavior of black holes to influence the creation of new galaxies or even new star systems? As we continue to explore black holes, another important question is whether or not we'll ever be able to interact with one directly. Currently, the event horizon is an impenetrable boundary, and getting too close to a black hole is far too dangerous. But scientists are constantly dreaming up new technologies that could one day allow us to safely study black holes up close. Some researchers believe we could send advanced probes, perhaps even human-crewed missions, into the vicinity of a black hole using protective shields or innovative propulsion systems that could withstand the extreme forces at play. One of the more out-there ideas that's being explored is the potential for creating safe zones near black holes, regions where we could study them in detail without the risk of crossing the event horizon. This would require us to develop technology capable of surviving in the intense gravitational fields near a black hole, and possibly even creating stable orbits around the event horizon. The idea of sending a probe or even a spacecraft into these regions would allow us to gather data from within the black hole's gravity well, possibly unveiling new physical laws or quantum phenomena that we've never encountered before. Of course, as we push forward into this new frontier, ethical questions are bound to arise. With all this incredible power at our fingertips, how will humanity choose to use it? What responsibility do we have as we begin to manipulate the very forces that govern the universe? As we harness the energy of black holes or even attempt to travel through their strange, warped spacetime, these are questions that will shape the future of black hole research. On the societal front, it's possible that in the coming centuries, black hole research could become a central part of humanity's culture. We might see entire civilizations, not just on Earth but across the galaxy, built around the study and exploration of these mysterious objects. Imagine entire space stations and colonies dedicated to black hole research, where scientists, engineers, and explorers work side by side to uncover the deepest secrets of the universe. These stations could be the scientific hubs of the future, where breakthroughs are made that change our understanding of existence itself. And let's not forget the possibility of interstellar travel. With the energy and technology we'll gain from our relationship with black holes, it might not be long before humanity is exploring planets around other stars, or even venturing into entirely different galaxies. Using black holes as gravitational slingshots, traveling to the farthest reaches of space could become a routine part of exploration. The future of black hole research is, without a doubt, one of the most thrilling areas of scientific discovery. We're poised at the edge of understanding, and each new breakthrough brings us closer to unlocking the true potential of these cosmic wonders. Whether it's using them for energy, manipulating space-time, or even venturing into other dimensions, the future of black holes is as limitless as the universe itself. As we wrap up our journey through the cosmic mysteries of black holes, it's time to step back and think about the bigger picture. Beyond the mind-blowing science, black holes force us to confront some of the most profound philosophical questions about the universe, existence, and even the nature of reality itself. As we dig deeper into their mysteries, we're not just expanding our knowledge of the cosmos, we're also expanding our understanding of ourselves. One of the most striking philosophical implications of black holes is how they challenge our understanding of time and space. The fact that black holes can warp space-time to such an extreme degree pushes us to question what we truly know about the nature of the universe. Time, as we experience it, is linear. It moves from past to present to future. But near a black hole, time behaves differently. As we've discussed, time slows down as you approach a black hole's event horizon, and from the perspective of someone far away, it seems to come to a stop. This phenomenon, known as time dilation, forces us to reconsider our entire relationship with time. If time can be warped so drastically in certain regions of space, what does that say about the nature of time itself? Is it an illusion, or is it a malleable aspect of the universe that we can eventually learn to control? But it's not just time that black holes challenge. They also challenge our understanding of causality, the principle that events in the universe are connected by cause and effect. When we talk about the singularity inside a black hole, we're talking about a point where gravity becomes so intense that the laws of physics as we know them break down. Some physicists believe that at the singularity, all the information about the matter that fell into the black hole is lost forever, a concept known as the information paradox. This creates a deep paradox within our understanding of the universe. How can information be lost if the laws of physics are supposed to preserve it? Does the destruction of information inside black holes mean that causality itself is not as reliable as we thought? This is where things get even more philosophical. If information can be lost, does that mean that the universe is fundamentally unpredictable or even chaotic? If the past is erased as it falls into a black hole, what does that say about the concept of free will? Could it be that events, no matter how big or small, are not as fixed as we think, and our place in the universe is more fluid than we realize? Then there's the idea of the multiverse, the possibility that black holes could be gateways to other universes. This idea, which has gained traction in recent years, proposes that black holes could serve as tunnels to alternate realities, where the laws of physics may be entirely different. If this theory holds, it would mean that every black hole might lead to a new universe with its own unique properties. In this view, the universe we live in is just one of many, and the event horizon of a black hole could be the border between our universe and an entirely different one. The implications of this idea are nothing short of mind-boggling. It suggests that the universe we see, with its galaxies, stars, and planets, may just be a tiny fraction of the vast, infinite multiverse. And what about the very concept of existence? If black holes are capable of erasing information, does that mean that nothing is truly permanent? Does everything eventually get sucked into oblivion? Or is there a deeper layer to reality that we're missing? Something that might offer a more profound meaning to existence? If everything falls into a black hole and disappears, does that mean that everything we experience is meaningless? Or does it suggest that the universe is simply undergoing a process of transformation that we can't yet comprehend? These questions touch on deep philosophical and existential issues about the nature of life, death, and the cosmos. Furthermore, black holes force us to reconsider the idea of infinity. The singularity at the center of a black hole is a place where theoretically the laws of physics break down and matter is crushed to infinite density. In many ways, the idea of infinity is something that we struggle to fully understand. We can imagine the concept, but infinity is something that we can never experience directly. Black holes bring us face to face with infinity, and in doing so, they challenge our ability to grasp the true nature of the universe. What does it mean for something to have infinite mass or infinite density? Can we even begin to wrap our minds around this concept? And how does it fit into our broader understanding of the universe? At the same time, black holes push us to consider our place in the grand scale of the cosmos. They remind us just how small we are in the vastness of space. When we think about black holes, objects so massive and dense that they can devour entire stars and warp the very fabric of spacetime, it can be humbling. It's easy to feel insignificant in the face of such cosmic giants. But at the same time, black holes also remind us of the incredible power of human curiosity and exploration. After all, despite their seemingly insurmountable mystery, we've managed to probe their depths, understand their mechanics, and even capture images of them. We've unlocked their secrets through ingenuity, persistence, and the drive to understand the unknown. In a way, black holes offer a paradox of their own. They're objects of destruction, but they're also windows into a deeper understanding of the universe. They force us to confront our limitations, but they also inspire us to reach beyond them. The more we learn about black holes, the more we realize that we're not just studying distant objects in space. We're studying the very fabric of existence itself. The mysteries of black holes, with all their strange and paradoxical qualities, touch on the deepest questions of life, death, and the nature of reality. As we continue to explore these cosmic giants, we're not just uncovering the secrets of the universe, we're learning more about what it means to be human, and what it means to exist in a universe that is far more mysterious and awe-inspiring than we ever imagined.